Firstly, thank you for a very interesting conversation here. I was thinking for two questions in one, if I may. What has been one of the biggest breakthroughs in the last few years in your specific areas, and maybe what are you expecting in the next 5, 10 years to be another big breakthrough?
Great question. Milia, do you want to start?
Yeah, I can start. I think we touched on this earlier. It's about the invasive technology. So it answers both questions, like the breakthrough and where we're going, because it's still early stage technology. And it's a combination of surgical procedures, surgical interventions, as well as getting that EMG technology up to date and more invasive. So when you think of like bionic reconstruction, you have potentially an arm that's attached internally to the rest of the limb with a rod, and inside there you might have a sensor reading the electrical activity at really low levels, so you're getting quite a high density of information, and then continuing from there, the technology in terms of how we train that information and the information that we can get from that is really expanding. So you might get lots of different signals coming down through the nervous system, but you don't see them all at once. And so what you can do with the signal is break it down into the different parts and the different movements that you might be affecting on individual muscle fibers. So you're really getting this high density of information and being able to then control the prosthesis. And then it also goes back in terms of sensory feedback. So then if you can internally stimulate some of these muscles, that helps as well. So yeah, it's a mix of things: the surgical reconstruction, the technology itself, the sensors, both ways. And then, of course, you need further developments with the hands themselves. But yeah, that's the sort of the direction that research is going in at the moment. Yeah.
So for me, and I'm going to give a non-technical answer, one of the biggest breakthroughs has been the conversation piece around human augmentation. So it is still quite a new term, but we have seen government policies, white papers, ministry papers, the debate we're having today. It's entering the sort of consciousness as a field of its own right. That's really important, because that then means we can start to answer your question around the 10 years of what really happens when we bring a range of technologies together. And for me, it's that range of technologies that's where lots of the potential is. So the exoskeleton work that's been done in stroke rehab, fab. When we start translating that into workforce, where someone's working in a factory, how does that get combined with sensory feedback, with electrical stimulation, with your smartwatch monitoring your vital signs continuously? How's all of that information brought together and used to enhance an individual? So I think that's the exciting 10-year part, is that fusion. The breakthrough now is we're having all the conversations and recognizing that there are some real challenges, both in terms of the technology, but also in the regulation, ethics, and policy.
Yeah, good answer. Yeah, I guess yes, I agree with everything that's just been said. Also, just kind of all the development that's happening around control. I think control is definitely the bottleneck for this kind of technology. Has been for prosthetics for a long time, but also a big challenge for augmentation technology as well. I don't think that kind of true augmentation exists just yet, especially with kind of motor augmentation, like with my thumb, for example. I'm piggybacking off my toes. I'm utilizing my toes, so I can't run around and use the third thumb. So it's still kind of, there's still an impact on my body. I think true augmentation exists when it's zero impact controlling purely something extra. So that's kind of where an exciting kind of space will be. And also impact can be also defined as cognitive load. So just because it's perhaps brain control doesn't mean it's perhaps not a cognitive impact. And then exciting stuff I'm excited about for the future is kind of any material development. So 3D printing, I love kind of working with new materials. This version of the thumb is very, very different from my first prototype in 2017 because of the materials that have now been developed in the 3D printing space. I think really exciting 3D print area is kind of biological 3D printing as well. So in the future, will we be able to design with kind of more biological material rather than just purely kind of mechanical or physical materials. So, and then to be able to kind of, develop that kind of space, which is a bit kind of out there, but it's exciting.
So sci-fi.
Yeah.